All right, so on this next page, it says representing relations, and a relation can be represented in one of four ways. Okay, so we're going to list all four of them out. So the first way is exactly what we've seen so far, which is a list of ordered pairs. The second way is through a graph, which you guys have seen as well. All right, so second way is through a graph. The third way is through a table. And then the last way is through a mapping. So we've already seen them represented as a graph and as an ordered pair. So the only way that we're going to now investigate it is through a table and through a mapping, okay? So the table is pretty easy. All the table is that we're just matching up the x and y value in this chart. So I'm just going to go ahead and match up -1 and 3 in this chart. And you have to just make sure that if you look straight across on that row, it's going to match, all right, that same ordered pair, okay? So let's try the next one, -3, -5, and I'm going to write that down, -3, -5. All right, we got 6, 2, and I'm going to represent that in that chart as well, 6, 2. And let's keep going just straight down the line. So 2, -2, 0, -4, and then 4, 0. So pretty easy, okay? Now the mapping is a little bit different. So on this one, what we're going to do in this first bubble, we're going to write our domain. And that includes the fact that we're not going to list the same number twice. And then this one right here is going to be our range. So I'm going to list it vertically. So I'm going to take my domain and I'm going to list -1, -3, -6, 2, and then I'm not going to relist it again, all right, that -3, but straight and vertical, -1, -3, 6, and then 2. And then on the other side, I'm going to list my domain. So I'm going to list 2, -5, 2, -2, and 4. All right, so again, I'm going to list 2, -5. I'm not going to relist that other 2, so then I have another -2, and then +4. So once you have those written vertically in your bubbles, all right, we're going to now draw arrows to connect them to show the ordered pairs. So I'm going to say -1 goes to 2, all right, so I'm going to draw an arrow connecting them, okay? I'm going to say -3 goes to -5, connecting them. Same with 6 to, okay, sorry, I made a mistake here. So 6 is going to go to 2 as well. So I'm going to now have 2 arrows that are going to 2. I'm going to have 2 going to -2. And then I'm going to have 2 arrows coming from -3 down to that 4. And there we go. There are relations represented as a table and then as a mapping. So our last big idea is functions, all right? And what's going on with functions is the definition is not going to help us, all right, very much. But once we get into the examples, it's going to make more sense. But here's the definition. Feel free to pause so that you guys can follow along. So what a function is for every x value, there is exactly one y value, all right? So for every x value, there is exactly one y value. So let me show you what this means, all right? Here's the process, okay? So it says on this next example, determine if the following relations are functions, okay? So here is what you do. The first thing that you're going to do is you're going to look at your x values, all right? So I have -1, -4, 1, and 8. And what you're looking for is, do they repeat, right? Are there duplicates, all right, in that domain among your y values or x values? And so I have -1, I have -4, I have 1, and I have 8. And because none of them duplicate, my answer is yes, this is automatically a function. All right, so as long as those numbers in the domain don't duplicate, your answer is automatically a function, okay? But let's compare it to this one right here. So if I go through and I look at my domain again, I have 3, I have 13, I have 3, and I have 8. And I would start seeing that I have 2 3s in there. And if you notice, this 3 is connected to the 1, and this 3 is connected to the 7. So I can say automatically, this one is no, because you cannot have the same number, all right, being connected to 2 different numbers. All right, so that's not allowed. All right, let's try this one. So let's say I have 2 connected to 9, I have 2 connected to 8, and I have 2 connected to 0. So if I wrote those out as ordered pairs, I would have 2, 8, I would have 2, 9, and then I would have 2, 0. And if you look at all those x values, all right, I have 2, 2, and 2. And if you notice, that's problematic because we don't want them to duplicate. So the fact that 2 is connected to 8, 2 is connected to 9, and 2 is connected to 0, this is not a function. All right, let's try example 4 though. All right, this time 1's connected to 8, 2's connected to 8, and 3's connected to 8, right? Now if I wrote those out as ordered pairs, 1, 8, 2, 8, and 3, 8, and I look to see at my x values, I have 1, I have 2, and I have 3, automatically I'm going to say yes, all right, this is a function because none of the x values are duplicating. So really all you're looking for is do your x values duplicate. All right, let's try this one, okay? So I'm going to look at my x values. I have -6, I have 87, I have 31, and I have -10. I'm not even going to look at those y values because automatically I can say, yes, this is a function because none of those x values duplicate. But if we look at this example, I have 3, -8, 55, and 3, and 3 is connected to both 1 and 10, and automatically I'm going to say no, all right, because that can't happen. You can't have an x value that's connected to both 1 and 10. Okay, all right, so our last, actually I'm going to pause here and then we'll come back for vertical line test and finish up the rest of these notes.